Well, hey there, kiddos. I hope you enjoyed your surprise long weekend. And so here we are back 4 days until spring break, and we're going to talk about factoring special products. Before we get into this, I want to tell you a special note, okay? If these shortcuts, because that's basically all they are, these shortcuts that I'm going to teach you in this video today don't work for you, or you can't seem to remember them, or they make you confused, you can always, no matter what the situation, take the polynomial and factor it just like we've been factoring everything else. You do not have to memorize the shortcuts, but they are very helpful if you do get to know them. And special products, they're special, and so they have shortcuts, and that's why we talk about them, because the shortcuts do come in handy if you start to recognize them. The first special product we're going to talk about is something called a perfect square trinomial. And so it's a trinomial, it's got 3 terms, and it's a perfect square. And the reason it's a perfect square is because the first term and the last term of it are perfect squares. And then the middle term is 2 times the square root of the first term and the last term, which we'll talk about. There are 2 ways you can see it. It can either be a squared plus 2ab plus b squared, or it can be a squared minus 2ab plus b squared. What it can never be is have a minus b squared. This has to be a plus, otherwise it's not a perfect square. Because you remember, we can't square a number and get a negative. These are the rules for factoring them out, but I'm going to go over this more. So you should have this, you don't even have to write it down. A trinomial is considered a perfect square if the first and the last term are perfect squares, and the middle term is 2 times 1 factor from the first and 1 factor from the last term. And I'm going to show you what I mean. Every time we do this, we're going to check to see if it's a perfect square by seeing if these 2 things work. And if they work, then factoring is a breeze. So let's go to the next page and let's look. First things first, we're going to determine whether or not each one of these is a perfect square, and if it is, we're going to factor it. If not, we're going to explain why it isn't. So, this first one, number 1, 4x squared minus 4x plus 1. Well, the first thing we want to look at is the first term and the last term a perfect square. So, 4x squared. Well, the factors of 4x squared happen to be 2x and 2x. Well, that's something times itself, so yes, that's a perfect square. The next term is 1, and the factors of that are 1 times 1. Well, that's still something times itself, so again, perfect square. So that part checks out. Now we have to check the middle term. So here is how the middle term works. In order for it to be a perfect square trinomial, then the middle term is one of these factors, 2x, one of these factors, the 1, multiplied by 2. And so let's check it. 2x times 1 is 2x, and 2 times 2x makes 4x. It's okay that it has a minus sign in front. We're not worried so much about the sign, but about the number, so this checks out too. So first term works, last term works, middle term also works. Yes, this is a perfect square trinomial. Since it's a perfect square trinomial, my 2 factors are super duper easy. Square root of this one, which is 2x, square root of this one, which is 1, and this time it has a minus sign in the middle because of this minus sign right here, and so my 2 factors are exactly the same. If you don't want to write them out both, you can just write it once and say it's squared. They mean the same thing. The tricky part about this is going through the test. And just like with what you did today, everybody was like, oh, this takes so many steps, it takes so long to factor. Yes, it can. But it's because it's a new process for you. Once you get into the process and you do it over and over and over, you'll get better at it, you'll get quicker at it. Same thing with this. I do not write this mess out every time I look to see if something's a perfect square. All of this happens in my head. You will get to that point as well. Excuse me. So let's check another one. So I have 81x squared plus 90x plus 25. And first thing I want to do is see if it is a perfect square trinomial. So I got to check the first term and the last term. First term is 81x squared. Well, 2 factors that make 81 are 9 and 9. So I have 9x and 9x. So yes, that's a perfect square. 25, hopefully you all recognize, is 5 times 5. So that's a perfect square, so we're good. So now let's check the middle. So it's got to be 2 times one of these factors and one of these factors. And when I multiply that, 2 times 9x is 18x, and 18x times 5 happens to be 90x. So yes, this one checks out also. So this is also a perfect square trinomial. So when I factor it, the square root of 81x squared is 9x. The square root of 25 is 5. Because this is a plus sign, I put a plus sign here. And both factors are identical. Or you can write it like this. They mean the same thing. So now let's look at the next one. Let's see if it's a perfect square trinomial or not. We'll check it first. So the first term, 9x squared. Well, 3x times 3x, so that one works. And then 64, that's 8 times 8, so that one's a perfect square. So now let's check the middle. So I have 2 times one of these times one of these. Well, 2 times 3x is 6x, and 6x times 8 is 48x. This one does not work. So no, this is not a perfect square trinomial because this number is not the same as the number in the middle. My middle term doesn't work. Not a perfect square trinomial. It can still probably be factored. You might be able to pull out a GCF for here. Maybe not. But you might still be able to do the box method and factor this, but for now, since we're just dealing with special products, it is not a perfect square trinomial. It doesn't get factored. You just write the word no. So let's move on. We have a couple more. I'm going to pause for just a second. I'm going to let you check to see if these are perfect squares and factor them, and then come back and check your answer. So you'll see my first one, I've already figured out it's going to be a perfect square trinomial because x times x is x squared, 2 times 2 is 4, and then the middle term is 4. And so my factors are real easy. Square root of x squared is x. The square root of 4 is 2. There's a plus sign here, so it becomes x plus 2 times x plus 2, or x plus 2 squared. The next one, same kind of deal. X squared is x times x. So that one's a perfect square. 49 is 7 times 7. So that's also a perfect square. And then your middle term is 2 times x times 7. Well, 2 times 7 makes 14 times x is 14x. That one also checks out. So this one is 2. So I have x minus 7 because of the minus sign there, and x minus 7, or x minus 7 squared. So that is perfect square trinomials. If it doesn't make sense and you don't know how to check it and it's a lot of work and too many steps for you, you can just factor them using the box method. I'm not going to show you that because I'm hoping you've had enough practice by now, but you can multiply these two, do the x and do the t and check it all. You can still do it that way, but the shortcut makes it really easy. So a rectangular piece of cloth must be cut to make a tablecloth. The area needed is 16x squared minus 24x plus 9. Find an expression for the perimeter of the cloth. Well, to find the perimeter, I've got to know how long each side is, which means I've got to factor this. And here's the first thing I noticed. This is a perfect square because 4 times 4 makes 16 and x times x is x squared. This is also a perfect square because 3 times 3 is 9, which means all I got to do is make sure my middle term works, and factoring's easy. So I checked them out. 16x squared is 4x and 4x. Like I said, 9 is 3 and 3. And so my middle term is 2 times 4x times 3. And it doesn't matter order, so 2 times 3 is 6. 6 times 4 becomes 24x. That one checks out. So this is a perfect square trinomial. Factoring it is simple. One of these factors, one of these factors, and then the minus sign because that's what's in the middle. And I get them twice because I have to have 2 factors. And so each side of this is 4x minus 3. Well, if I want to find the expression for the perimeter, since it's a square and all the sides are the same, I can just do 4x minus 3 times 4 because there are 4 sides to my square. Or I can label all 4 sides and I can add them up. Either method works. I don't care which one you want to use. They'll both get you to the right answer. I'm going to multiply by 4. So 4 times 4x makes 16x, and 4 times 3 makes negative 12, and so the perimeter is 16x minus 12. which is what you'd get if you add out all these up. Now, difference of two squares we've talked about, so I'm sort of going to brush through this because we talked about this in the video for the night over the weekend. A difference of two squares is when you have just that. You have two terms that are being subtracted, and both of the terms are perfect squares. So you have a squared minus b squared. If this says plus right here, it's not a difference, it's a sum, and it doesn't work. But factoring, it's really easy, a plus b and a minus b, and so we're going to practice. So we're going to look at it first and see if it's really a difference of two squares. 1, yes, is a perfect square. 4x squared is also a perfect square. We can check it. 1 is 1 times 1. 4x squared is going to be 2x and 2x. So it is a perfect square. Put my times signs there. So factoring it is really easy. It's one of these and one of these. So it has 1 and 2x. One term is minus. The other one is plus. Factored. Now the next one is a little bit different. Okay, I have 3p squared minus 9q to the fourth. Well, first of all, it's not a perfect square trinomial, and I can tell you that because 3 is not a perfect square. So this is not a difference of two squares because 3 is not a perfect square. Okay? 3 is not a perfect square. There's your explanation. Okay? And so that's how I know it's not. So I'm done. But now look at the next one. I have x to the fourth and 25y to the sixth. Well, 25 is certainly a perfect square. Now we got to talk about the x to the fourth and the y to the sixth. If you will remember the rules for exponents, this exponent itself doesn't have to be a perfect square because when you are multiplying things that are the same, you don't multiply their exponents together, you add them. So x to the fourth is the same thing as x squared times x squared, because when you add those exponents it makes a 4. So when you're looking at the exponents to see if they're a square, you have to say, is there something plus itself? That only works for exponents, but this is a perfect square because this times itself makes x to the fourth. 25y to the sixth is the same way. 5 times 5 is going to make your 25. And then to get y to the sixth, I have y to the third and y to the third, because if I add 3 plus 3, it makes 6. And so when I'm dealing with exponents, I'm dealing with a number plus itself. When you're dealing with coefficients, you're dealing with a number times itself. But this is a perfect square a difference of two squares, because these are both perfect squares. So my factors are x squared minus 5y cubed and x squared plus 5y cubed. I ran out of room. These are the two factors. Okay, so you have to be real careful when you're dealing with difference of two squares. Just because that doesn't say squared doesn't mean it's not a perfect square. So let's look at another one. So I want you to pause for just a second, try them, see if they are really a difference of two squares, and if they are, factor. So for this first example, it is a difference of two squares because 100x squared can become 10x times 10x. And 4y squared is 2y times 2y, and so my factors are 10x minus 2y and 10x plus 2y. The next one is also a difference of two squares because p to the 8th power is the same thing as p to the 4th times p to the 4th, and so 4 plus 4 makes 8, makes it a perfect square. The 49q to the 6th is also a perfect square because 49 is 7 times 7, and then my q's become q to the 3rd times q to the 3rd because 3 plus 3 makes 6. So my two factors are going to be p to the 4th minus 7q cubed and p to the 4th plus 7q cubed. So that is difference of two squares. That's how we factor it. So you've got two different types of special products. You've got perfect square trinomials, and you have difference of two squares. Difference of two squares is much easier to recognize. It also shows up just as frequently as the other. So the one that you really should work on is recognizing a perfect square trinomial so that you can use that shortcut whenever necessary. I will see you tomorrow, and we'll practice this then.